In lesson 4.7, we are going to talk about how to use calculus to optimize different situations. So those are going to be things like minimizing and maximizing quantities. So remember, to find relative minimums and maximums, we take our derivative and we set it equal to 0. So that's going to be our calculus technique. What we often have is that we have a primary equation that we want to, something that we want to maximize, and then there's some sort of secondary equation that has constraints on it. So we'll see lots of examples of this. So the first one, we have a design for an open box with a square base, and the surface area is 108 square inches. There is a picture of this on page 256. We want to know, what are the dimensions that will produce a box with maximum volume? So I'm going to start by kind of sketching this here so you can see what it is. So it's some sort of open box. Maybe it looks like this. We know that it has a square base, so I'm just going to call it x and x, but it's not necessarily a cube, so I'm just going to call the height h. So what we want to maximize is the volume. So the primary equation is going to be for the volume of this, which is going to be x squared h. And we want to take the derivative of that and set it equal to 0 because we want to find our minimum or maximum. However, we don't want to do it yet because this has two variables in it, and we don't really want to take the derivative with two separate variables. So our secondary equation is the other information they gave us, and they gave us information about the surface area. So the surface area, I don't know why I can't write there. The surface area, if we look at this, one side is going to be xh. There's going to be 4 of those, so 4xh. Plus the bottom is going to be x squared, and we only have one of those because this is an open box. Okay, so there's no lid to it. And they told us the surface area is 108. So what we want to do is solve the secondary equation for one of our variables. And it's going to be a lot easier to solve for h. So that's what I'm going to do. I'm going to divide both sides by 4x, which is going to give us, let's see, 108 divided by 4 is going to be 27. Minus x over 4. There, I think that's right. Okay. Now what we're going to do is we're going to plug that in up into this primary equation. Okay, so this primary equation becomes x squared 27 over x minus x over 4. And then I'm going to go ahead and distribute that x squared. So that gives us 27x minus 1/4 x cubed. Okay, so now we have a primary equation all in one variable. So now what we'll do is take the derivative of this, which is going to be 27 minus 3/4 x squared. And we're looking for relative minimums and maximums. That happens when the derivative is 0. So we set that equal to 0, and we're going to solve this. So we get 27 equals 3/4 x squared. I'm going to multiply both sides by 4/3, and that'll give me 36 equals x squared. I'm going to take the square root of that. Now, technically, it's plus or minus 6, but since x is the dimensions of this box, I'm just going to take the positive one, so 6. And then to find out what h is, because remember, we want all of the dimensions, not just x, I'm going to come back here, let's change colors here, come back here to this secondary equation and just plug in for x. So I get 27 divided by 6 minus 6 over 4. And when I finish that, we end up with h equals 3. So those are the dimensions of the box that will maximize the volume. So when you're solving these applied minimum and maximum problems, kind of the steps that we're going to work through is you want to identify your knowns and unknowns and make a sketch. A sketch is really, really helpful. So then you'll write a primary equation, and that's the thing that's going to be minimized or maximized, okay? And it'll say in the problem So you'll actually look for the words minimize or maximize. So that way we know what it is that we're trying to find. Then we want to make sure that the primary equation only has one variable in it. And that's where you might need a secondary equation to do that. We don't always have a secondary equation, but usually we do. In some problems, we even have two secondary equations. Also, make sure you think about the feasible domain, what makes sense in the problem. In our last problem, negative answers didn't make any sense, so we excluded those. And then we're going to use calculus to find the maximum or minimum. And the way that we do that is we will take the derivative and set it equal to 0. Okay, so we'll check out another example in the next video.